This video is going to walk you through the introduction to sound. So what I have here is a speaker, and I can play the speaker, and we can make it do some waves. And you'll see the cone goes in and out, in and out, and in and out. And what that does is that sends the sound waves out. I'm currently not playing the sound because it's really annoying. But what we're going to do is we're going to answer some of these questions. Number one is the amplitude of a sound wave is related to what property of the sound itself. So I'm going to play the tone and then I'm going to change the amplitude and you can see what property that's related to. Hopefully you can hear that. It's not too annoying. So as I go with a bigger amplitude or a smaller amplitude, hopefully you can hear through the video that the loudness changed. So the answer to number one, the amplitude of a sound wave is related to what property of the sound itself? It's loudness. Number two, the frequency of the sound wave is related to what property of the sound itself? All right, let's turn this back on. Hopefully you can hear this over the video. I'm now going to go to a higher frequency. That's a lower frequency. So frequency of a sound wave is related to the pitch of the sound. The next question is a little bit more difficult. It says, what kind of a wave is a sound wave? How do you know? What I want you to do first is I want you to remember, don't look back in your notes yet, but remember, try to remember, what are the two types of waves, what properties are used to classify them. And then what I'm going to show you here is I'm going to show you the air particles. So the medium that a sound wave travels through is the air. So nitrogen and oxygen and all that stuff. These little red ones are just so you can try to follow one little air molecule. So what I'm going to do is I'm going to turn this on. And I want you to follow one, maybe that one right there. Now I want you to decide which kind of a wave is it. Now if you couldn't remember the two types, it's longitudinal and transverse. Now if you don't remember the difference, I want you to try to remember first, and then if you still can't remember, go back in your notes at the beginning of the packet with the vocabulary and look at the difference between the two. So you need to decide, is this a longitudinal wave or a transverse wave? I'm going to increase the amplitude here. You'll see them move more. You see the wave is moving out away from the speaker. And any of these little red air molecules, really there aren't molecules of air, but are also moving towards the speaker and away from the speaker, and towards the speaker and away from the speaker. So they're moving in a direction that's parallel to the propagation of the wave, of the energy that's going out from the speaker. And so when a particle moves in a direction that's parallel to the direction the wave is moving, it is a longitudinal wave. Now let's go to number 4. If you measure the air pressure over time at a single position, as a constant pitch sound wave passes through it, what does the air pressure versus time graph look like? So I have a little graph here. I'm only need one sensor. And we're going to look at what that graph looks like. So what's happening here is we see the pressure going up and going down and going up and going down. And this is over time at this one spot here. So you'll see this space sort of between the waves is where there's low pressure. So that would be like a trough. And then let's see if it'll move. Yeah, there we go. This space here, sort of the crest, is the high pressure. And so we go low to high and low to high and low to high and low to high. So we have a crest here and we have a trough here. These waves, sound waves, are longitudinal. However, if we graph them as pressure versus time waves, they look like transverse waves. And it's way easier to draw a transverse wave than it is to draw a longitudinal wave. So when we represent sound waves on paper, we're almost all the time going to draw them as a transverse wave because then we can do that as sines and cosines, and we're used to doing that. All right, that is the end of this video.